So we have people joining. Hey guys.
Hello, hello. Yeah, hello everyone. Hello, hello Mike, Victor, Yulia, Elena, Valeria, and hello all attendees joining right now.
Oh.
All right. So we just started our webinar. So what will happen next couple of minutes? We will be waiting to allow people to jump into webinar. And during this time, we will let you guys see, for those of you who didn't use Zoom, you will have chance to look at it. And during this webinar, we will be using our chat in webinar just to make some messages to everyone. And as well, we have separate button called Q&A. So if you have particular questions you would like to be answered during the webinar, please post them there so that we won't miss them in general chat. And we will try to address all the questions you will have during the our session. And yeah, get ready to enjoy it. All right. By the way, guys, currently you are disabled to speak right now, but at the same time you can drop messages to the chat, and you can say hello to everyone just to try it out and to check if it works at all. Hopefully it will. Yeah. Hi, Anton. Hi, Mike. Alexei. Oh yeah, I start seeing messages. Mikhaila, Igor, Pavlo.
Oh, can I have a word now? Just one
Sure.
moment for all of you guys. You have option to send a message to all panelists and attendees, but some of you sending messages only to all the panelists. So choose an option attendees as well so that everyone could see your message. Sorry for interruption.
Yeah, panelists and attendees.
And Igor still sent us to panelists.
All right, so good news, chat works. By the way, guys, have any one of you already attended Google events before? While we're still waiting, yeah, okay. We'll have some time to check our chats and just get some information from your side. All right. Okay, I see Natalia posted a question to Q&A, but it was actually an answer. All right. And anyone attended SoftServe events before? All right, no. Oh, architecture workshops. Sergey, hi Sergey. Good to see you again. Yeah, SoftServe events, yes. Google Cloud, no. From Roman. Pavlo attended previous big data workshop. Unfortunately, not yet. And all right, while we still have several minutes to allow people to join, I would like to probably describe and build expectations about this current workshop we're going to have today. And what is the difference to the previous one? Previous one was quite limited in terms of attendees who can attend that. So we were oriented on architects working with big data already. And this workshop will be more basic, so more oriented to people who are good at programming, engineering at the same time, never worked with big data, and maybe never worked with cloud platforms. And what is our goal today is to share information, what is data engineering in general, how it is working on Google Cloud Platform, and let you enough information to start if you wish to switch to big data world. And because from my experience, I have a lot of conversation with people who want to join this movement and start working in big data area. And the most often question for people is like, where can I start, right? What is the most essential thing to know when you start working with big data? And basically, this webinar today is more oriented to people who have engineering experience and want to start working with big data, and to help people to make this switch. So if you guys join in today, like having more like senior level and architectural level in big data, probably this session will be oriented not sharing some advanced level and advanced techniques, but rather a basic level to help different level of people to understand big data and Google Cloud Platform. At the same time, it will be dedicated to share a bit structured way of thinking what is data engineering, and what topics should be covered if you want to become a good data engineer. So like, yeah, at the same time, like while we have 3 minutes more, like based on our schedule, we have like a small talks right now, and 3 more minutes. Maybe you can send in the chat what would you like to hear. Of course, we have our agenda and pre-prepared. At the same time, if something is not here, but it will be possible to put within existing context, I will be happy to do so. So please use our chat and post what topics would be interesting to hear today. Maybe Mike, you want to speak? Yeah, we will have our introductions like a bit later, but maybe just to have anything to say.
Yeah, sure. I mean, I'm privileged to be here to support the SoftServe team, Mike from Google. I think this will be a great session. Hopefully it's the right level for everybody, and everybody's keen to get started and learn a bit about some of the technology and some of the subject area. As you'll know, there's a huge amount more you can learn, and we've got some resources for you at the end to help you get started or take those next steps. I'm sure Vitaly and the team would be happy to talk to you afterwards if you've got any more questions.
Yes, so there's a question from Helena, if this webinar video will be available. Yes, we will record this. By the way, Alena, Valeria, just to check, we started recording, or we'll start in a couple of minutes just in case. It's a good point. I have a question from Maxim. How important is Hadoop these days? Many technologies use it under the hood, but does one need to use pure Hadoop daily? That's a very interesting question, right? So, and like here I would split this question into like pure Hadoop as a distributed file storage, and all the technologies built on top of that. So far, like we have seen like trend when a lot of companies moving from classical Hadoop systems to cloud providers, just to reduce cost of ownership and maintenance of the whole system. At the same time, if we're talking about Spark technologies, right, they still make sense these days. And even within cloud providers like AWS, Google Cloud Platform, Azure. So there are cloud native technologies like in Google, like data prep, Dataproc, my bad. Dataproc to run Spark workloads and Hadoop like workloads in cloud native way. And there are like third-party solutions for all the clouds, like Databricks, for instance, right, which still uses Spark. And a lot of code already created using those technologies. And for many companies, strategically, it does not make sense to just rewrite everything. Still, you know, some applications already work perfectly, and there's no sense to invest into rewriting because like new technologies available. Maybe some new workloads created on new technologies, but old workloads, we've seen like very successful projects where everything was just moved from on-premise to cloud platform, still using Hadoop, and it works just right. All right, yeah, it's time. Let's start our presentation. And just to reminding, if we not started recording, just please, I would like to ask. Started. Okay, thank you very much. All right. Everyone, welcome. So this is our second session together, joint session between SoftServe and Google, starting like contributing to community of big data in Poland and Ukraine. Currently, we started this in two countries. Maybe it will be broader geography later. Right now, we're still on our second sessions. So what is our agenda today? So we will start with introductions, who will be your host today, workshop overview. We will talk about data engineering in general, what it is and what should be covered if you want to become a data engineer, and how Google Cloud Platform works for data and analytics these days. And today we have planned some practical examples, very basic, just for beginners. And this session is oriented to beginners in big data and to people with no experience with data engineering at all. So let's start it. Today, here I will be your host. I'm from SoftServe. I'm leading Google Cloud Consulting in SoftServe. Together with me is Victor Shetyuk, who is our data engineer at SoftServe, and he will be leading our practice today. And of course, special co-host Mike from Google. Mike, you can have a couple of words to introduce yourself.
Yeah, sure. Hi, everybody. I'm Mike Lamb. I'm a partner engineer at Google. So I'm a technical pre-sales engineer, working particularly with some of our premier partners that we work with closely with our customers. So SoftServe is a favorite of mine. Spent a lot of time working with Vitaly and the team. I have to confess, and I will do at this point, that I'm not a big data expert like Vitaly and Victor. I'm a generalist. I work with a load of different technologies. My background is very much in infrastructure, working in enterprise, in data centers, really from hardware layer up to applications and middleware. But I have recently been learning big data. Last year, I took my data engineer certificate with Google Cloud. So it is possible, and it's very learnable. Lots of the same principles can be reused from whatever your background. So don't feel overwhelmed. I certainly did to begin with, but it's a very accessible area. So welcome, everybody. Looking forward to working with you on this.
Great. Thank you, Mike. All right, so a couple of words about SoftServe. Maybe if you haven't heard about this company before, like we work in IT industry, and like especially last years we start working with Google, and we become a Google Premier partner. And right now our cooperation is like on a very high level, and we have like very tight schedule and you know, pretty big pipeline. Just for instance, like within the last year, we started over 100 GCP projects. So in average, it's just 2 projects a week. Like we start in 2 projects every week, like together with Google. And that makes us thinking we're kind of understand this platform and know how to work with that and how to help clients with that. So we have like almost 5,000 of engineers and architects certified, which makes us like top 5, one of the top 5 companies in the world certified with Google Cloud Platform. We've done a lot of migrations, existing big data projects to GCP, and as a company, like based on our success with projects, we actually certified as a company in 6 specializations, like cloud migrations, data analytics, infrastructure, machine learning, IoT, and security. So this like high-level background and our experience with Google Cloud Platform. And let's move on. So what we will have during this workshop, as I mentioned before, we will going to talk about data engineering and explaining all the aspects and areas which are important to understand when you work with data. I will explain like very basic differences in storage organizations for like data projects. And we will have introduction for Google Cloud Platform from Mike. And then we'll start doing some practice just to show how easy it is to create simple data pipeline and to write some queries and analyze data within Google Cloud Platform. So let's begin. Data engineering, as I mentioned before, like I had a lot of conversations before to people who wanted to start their journey in data and analytics world, and the most often question was where do I start, and what actually like full landscape of topics and areas I need to understand to successfully start this journey. And here I tried to create one pager just to cover on high level all the topics and areas to learn. So first of all is data ingestion. It's like when you build a data analytic system, one of the things you need to understand how you ingest data into the system. Then storage, like it's another cornerstone of working with data, how you store and organize all your data on the platform so that it is easy to use it. Then processing, like what instruments, tools you use to process your data, prepare your data, how you actually build your analytics and make it possible to analyze and work with data you accumulated and took from different sources. And of course, most advanced thing like in data analytics is AI ML, how you work with artificial intelligence to move your understanding of data to the next level and to extract even more value from this data. And for data ingestion, so it is integration with external systems. It is topics related to batch ingestion, of course, to streaming ingestion, and like one type of streaming processing is like so-called CDC, change data capture. It's a very popular pattern when you ingest data in near real time from your databases. Again, storage, databases. Like as you probably know, there's like a wide variety of databases created, like relational databases, NoSQL databases, graph databases, document-oriented, key store, and so on and so forth. This is important to understand which database to choose for particular purpose. Then data warehouses. I will talk a bit more about databases, data warehouses, and of course, data lakes, because there are many questions. What is the difference and why I need like so different terms to just call my data? We will get back to this. NoSQL databases, as I said before. Another topic very important is data modeling. This is very important when you design, after you've chosen where you store your data, there are different design patterns and approaches how you model your data within those systems you've chosen. And data governance. It's not only about how you store this data and in which structure, but also how you make it available for your organization, how you distribute this data, and how you organize access to this data, what roles you introduce within the company to work with this data. Data processing. Of course, it's data transformations, calculations. When you work with big data, it's difficult sometimes to just get your answers to your data immediately. So you will be forced to pre-calculate your data somehow for some cases when it's needed. Data enrichment. So this is topic about how you make your data more useful, like combining different data sources and make a full picture out of different pieces of your organization. Data extraction, this is technique like about extracting data from existing data you have, and data distribution, how you actually, after processing, how you send this data somewhere, how you create all the data pipelines, and of course, orchestrating all of this. Analytics. Ad hoc queries, it is easy, right? It's when you created your data in somewhere in data warehouse or any other source, and make it possible to just analyze this data ad hoc, right? Letting your data analyst work with this data, create some environment for collaboration, working with the data. This is a topic about this. Reporting, of course, many companies, they do reporting like financial reporting, they do reporting for analyzing trends, they do regulation and compliance reporting for external audits or other requests from governance, from other institutions in according to law. Dashboarding, dashboarding. That's actually creating like the most actual information about your system, and with the most important KPIs you need to control over the time and constantly understand what is happening. Self-service BI. This is a topic about organization, like the whole environment for people who can discover like all variety of data collected from your enterprise, because sometimes enterprises have so much data and so complex data, so you need to create like separate environment to make it possible even to start understanding and digging deeper into your data and allowing your data analysts to work with that. Data mining, of course, it's about statistics and other mathematical methods to analyze your data and to extract some useful information from that. It's not AI/ML yet, right? But this is something like more science based than just writing queries. It's like different approaches how you work with that. And of course, the most advanced level of working with data is AI/ML for finding patterns in your data, doing smart predictions, automated design or decision making. So allowing your system to make decisions based on the data and situation in your organization. It's like very important part in creation of data-driven organizations, and that's very popular topic right now. And we work with a lot of clients who want to build this system and improve their agility to like to work in fast-changing business environments. And of course, very interesting topic like working with voice recognition, video, images processing, and any other applications of AI/ML. All right. Moving further, for people never worked with like data engineering, as I mentioned before, sometimes it's not clear what is the difference between database, data warehouse, and data lakes, right? For some of you, maybe like if you worked with just usual engineering and worked with some databases, it's like you probably heard about normalization techniques and like the golden third normal form for databases when you create them just to make data consistent. This is about databases, which work usually for operational environments. And here is like some cheat sheet for understanding normalization and denormalization, why and when you use it, right? So when you have normalized database, it's very consistent. It's optimized in space, so you don't use like a lot of volume of data. You able to work with this database fast, like in terms of like small pieces of information, like inserts, deletes, updates, like when you work with just one record or several records, but it's small subset of data. Like usually working with operational environments, like let's say in banking, like one transaction from one account to another, it's just touches a very small amount of data. And this is a situation where normalization works better, and it is required to be here to provide consistency of data and very efficient operations with small amounts of data. At the same time, data warehouses. It's quite different beast, right? In this scenario, you need to denormalize your data, creating completely different structure, right? So it's not normal form. In most cases, it is. It might be like star schema, like or just flat tables when you have everything in one table. And why would you need that? Because in this way, when you store the data, it has low consistency. It have like super high redundancy, like when you store the same thing several times. And it's very easy to make your data inconsistent when you update something in one place, but you forgot to update in another one, and your data start to be inconsistent. But at the same time, data warehouses, they are not for small pieces of updates, right? So usually data warehouse is used to accumulate data, like historical data over time, and put them in this format. And this format particularly useful for analytical workloads. So when you analyze not something about like small amount of data, you work with like whole data set, and you want answers to big questions like, what is my revenue last year? What is my revenue last year for a particular city, right? And like very big and high level questions, but at the same time, you need to analyze whole data set of data, like billions of records in one query. And this design of flat tables or just star schemas very useful, because you don't need to perform like a lot of joins to answer your questions, like all your data accumulated in like one piece. And what is most important, it is possible to run your process and parallelize it, right? You have parallel process and massive parallel processing, and many patterns like let's say even like MapReduce approach, which is like parent for all approaches currently used in Spark, in Apache Beam, in Flink. So they took this idea from old kind MapReduce, right? You split your data like and scale it horizontally between different servers, and you can write a query, and this query process the data in several pieces and collect your answer in one place. This is how it works. And for some people, maybe it's new term, data lake. What is data lake, right? In this case, sometimes in enterprise, it has so much different data and different data structures. Oh, I see I have 10 minutes left. I will speed up. This is the last slide probably from me. Data lake, you have so high variety of data. You don't even have time to create good structures for all the data collected from different places. In this case, like data lake for non-structured or semi-structured data can be used. It can be used for storing your documents, video, audio, like different formats of information, different structure of information. At the same time, you can organize well orchestrated access to this data and perform, let's say, machine learning and machine learning processes around this data, because machine learning work perfectly with like raw formats of data, and it's easier actually to have this data like as is, like in place, in one place. And that's why data lakes created. So hopefully I haven't created a mess around these terms, but maybe gave you some understanding of it. Lake house architecture. Yeah, it's actually it's interesting topic, and please post this in Q&A so that we haven't forgot about this. Unfortunately, right now I need to go further and pass word to Mike, because we're like on our schedule.
Thanks, Vitaly. I don't mind being a bit quick here. This isn't meant to be a sales pitch from Google. I just want to say a few words to introduce some of what we work with. So particularly in the area of big data and data analytics, Google Cloud has, say, a bit of a reputation. A lot of our customers are really, really keen to use cloud services for big data. And that covers all of the areas that Vitaly's just talked about. And that's really a strength that we see in the market, and we see that people are recognizing. If we could just move on to the next slide, please, Vitaly.
Yep.
So in the space of big data, our smart analytics vision is really to offer a dependable, production grade, enterprise grade data platform. We're trying to do that with an open and flexible philosophy. So you'll hear this quite a bit when you hear Google talk about the products and services that we create. We're trying to create an open ecosystem and an open culture. We fully embrace hybrid cloud. That's something that customers are interested in. They want to be able to move things, and we want to be able to support that. We want to apply flexible features. And as Vitaly said, right at the end of the data engineering slide, we want to add intelligence on top of the data that's available and provide new insights and new ways of analyzing the data with AI and ML. If we can move on again, please. Mm-hmm. So one of our products in this space, and probably the one that gets most interest and has been around in our product set for longest, would be BigQuery. So this is a new style of data warehouse, and a serverless style, I would say. So you may have heard of serverless and cloud functions and things in the context of applications running, where you just define a piece of code that you want to run, and you don't have to worry about any of the other machinery underneath. And that's exactly what we mean here in the context of a data warehouse. So BigQuery allows you just to create your data set, create your table, put your data in there, and start querying, start getting insights from that data. Now, as you heard earlier, I'm an infrastructure guy by trade. That's what I spent most of my career working with. So all of these items on the left, these are things that I've worked either with myself or with other database administrators or data warehouse administrators. So setting up the right hardware for the right scale that you need to support the data throughput you need, or the number of queries, how much data you need to store, performance tuning, monitoring, checking availability, all of that stuff. That was 90% of what, 85% we describe here, of what the DVA had to do, rather than spending time analyzing data. So that's the really exciting thing about BigQuery, and hopefully get to see some of that in a few minutes on the lab. One of the interesting aspects of that, I'll just finish on this slide, is that because of that serverless nature, when you're not paying for infrastructure, you're paying for two different aspects of using a data warehouse that again Vitaly covered earlier on the data engineering slide. One would be storing your data. So you pay a certain amount for data storage, and then you pay for the queries that you run based on the data that they process. And those two could be scaled entirely differently. If you move on to the next slide, just a few fun facts, depending on your definition of fun. A few fun facts on BigQuery. So in terms of data storage, we have one customer that stores 350 petabytes of data in BigQuery. We have a number of customers that are querying over 100 trillion rows. And we have some customers that run 10,000 concurrent queries across their data or more. And each of those aspects can be done fully independently. Just because you're storing 350 petabytes of data doesn't mean you need to have a query of that size or run that many concurrent queries. You can size the storage and the data processing completely separately. We move on again. I'll try not to spend too long on these next couple of slides. I'm sure you haven't come to hear about our customers, but our customers are saying things publicly about how much difference this kind of solution makes to how they run their business. HSBC is one of our biggest customers, certainly one of the biggest in EMEA. And they not only make cost savings and that kind of thing by moving to the cloud, but they're making their workloads faster and more flexible, and they're allowing them to do things in the cloud with the data there that they never could before. We move on to the next slide as well, please, Vitaly. You may not know of Sky. It's a large TV and satellite broadcaster and consumer brand in the UK here. And they use not only BigQuery, but a whole ecosystem of smart analytics tools and products on Google Cloud that let them stream data in real time, allow them to store and analyze that data in real time, to understand how the customers are using their set-top boxes, which content they're viewing, what they're actually what they're looking at, what they're actually watching. They can understand and suggest and recommend better products, better things to watch for their customers. And they can in real time do A/B testing to try out experiments for a subset of the population with maybe the layout of the programs that are presented, and allow them to change that, analyze that, and change that on the fly. I think now I'm handing back to Vitaly to give us a bit of a view on a reference architecture that hopefully puts together some of the components that we have in Google Cloud and show you how you might construct a pipeline.
Yeah, so I will not stop for too long on this picture. It's just like reference architecture of some like basic way the data platform can be organized. It just starting picture like used for initiating conversations with our clients to just say about like different parts of the system, like data lake can be organized with Google Cloud Storage, data warehouses, and analytical storages in BigQuery. And at the same time, as was asked previously about Hadoop, so Hadoop still here can be done on Google Cloud Platform using Dataproc and storing data on Google Cloud Storage. So it's still available here, and of course, working with streaming analytics and real-time machine learning and artificial intelligence, and of course, orchestration of everything. So this very basic and simple picture used to just initiate thoughts about building a system. Of course, in real life, it's a bit more complicated, and it can be like added a bit more services here on the picture, and with different dependencies on it. So let's move on, and probably here we have some time for questions and answers. Actually, previous question was about lake house architecture, and thank you, Dmitro, for this question. And this is another way to organize data in not only in cloud, but in general. So lakehouse idea built on the concept when you have a data lake with like your structured, unstructured, semi-structured data, all the mixture of data in your data lake. And at the same time, you build additional layers on top of that, helping to actually create kind of structure on top of unstructured data, right? So that you can work and treat your data like using some queries and running some processing on it, treating this as a data warehouse and maybe like some additional functionality to Lighthouse. First time I've heard about this concept, it was like several years ago when Databricks created even like not only like this term, but additional tools and instruments to work with this concept. And actually they implemented first version and vision of this concept. Then these concepts became so popular, like AWS start using this term as well, right? And like some time ago, I had a conversation with Databricks guys, and they actually were pretty, you know, arguing about like this term relates to AWS because they say we invented that, and right now all the all the fame came to AWS about this term. So yeah, of course there are pros and cons about this approach. Pros, of course, you can more fast create like your prototypes, start working with the data without huge investment into redesigning and thinking and keeping all consistency like for your data. From the same time, like any kind of abstraction, it comes for price of maybe performance and other like ways of like having problems, other problems with let's say inconsistency sometimes. But there are techniques how to improve situation. Yeah, pretty interesting concept. Sometimes it might be popular in GCP world when we build like federated BigQuery environments, when some data is stored still in Google Cloud Storage in raw format, but you can still make questions to queries to it. At the same time, like new step in it, like BigQuery Omni, which still in alpha version, but it will be available soon this year, when you can have data in several clouds, in Google Cloud Platform, in S3 buckets on AWS, and you can combine this data in one environment. So it will be available through standard APIs and web UIs of BigQuery. All right. Hopefully I answered a bit this question. Okay. So question from Halina. So how painful it is to migrate Oracle workloads to GCP? Basically, so we had several migrations like this, and it depends on the way how we migrate it. Of course, if we do, because there are different strategies of migration. It can be like lift and shift, lift and transform, or full re-architecture, right? So lift and shift works good if you use so-called service called Oracle BMS, bare metal solution in GCP. So Google currently supports this kind of migrations of Oracle workloads and databases, when you don't need to pay double price for licensing in Oracle as you would do if you just migrate it into a virtual machine, right? It's a usual problem Oracle caused, right? And for these situations, Google has a solution. You can Google it. It is Oracle BMS solution. If you re-architect it from the other hand, of course, you can use like if you're talking about operational databases, there's Cloud SQL, but Cloud SQL supports currently only 3 different databases like PostgreSQL, MySQL, and from recent times, Microsoft SQL Server. So hopefully I answered this question. And yeah, of course, to re-architect it and to rewrite queries to other thing, it would require more effort in terms of like design and moving everything. Okay. All right, guys, do you have any other questions? All right. Yeah, guys, if you have questions, just post them in our Q&A part of this Zoom tool set, right? And let's move on, or we can have a short break if you wish. like between the start our practice?
Guys, before the break, so you should receive an email, a couple of emails, to be honest, to participate in this practice lab. You need to set up Google account, Google Cloud account, and you need to attach a bank card. So please type plus in the chat or minus if you have set up already a credit card or not. Plus, 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 plus. Good. So we have 35 people and only 5 pluses.
Yeah, guys, don't be afraid. It will not charge you like immediately.
Yes, yes, yes.
Like,
So
it's just to confirm your real person.
Google gives you $300 as a gift for Google Cloud. So you just need to attach your card, and I promise you will not be charged at all, even if you spend all $300. And today we are going to spend $0 because Google has free tier, so you may run some services for free by limited amount of cases, and it's free, but you need to set up your card, to attach your card to your billing account. If not, we have a 5 minutes break. Yes, I'm going to share a link right now.
Yeah, guys. Now we have like five-minute break. If you want, you can spend them to like if you finish in preparation for your lab. Yeah, feel free if you need your time before we start in practice. So we will meet in 5 minutes and continue practice.
I'm going to leave at this stage, so I'll say thank you very much, everybody, so far for being a great audience, and hope you enjoy the rest of the practice session with Vitaly and Victor.
Thank you very much, Mike. Always pleasure to have you on our events.
Yeah, you're very welcome. See you next time. Good luck, everybody.
Thank you,
Hope to see
Mike.
you all again.
I hope to see you next
Cheers.
time.
Bye-bye.
And until
Cheers.
soon.
Bye.
So guys, this is a link. So for people who typed minus, we have a 5-minute break. So you can follow this link, take your card, and make a billing account and get $300 for free. But again, I promise that we will spend $0 and Google won't charge you even if you spend all $300 because Google starts charging when you move your billing account from trial to some sort of production. So don't be afraid, please. It's safe, I promise. So now is 6:53. Let's meet at 6:57 p.m.
All right.
Dali, please stop your sharing. I'm going to
Yeah.
share my presentation.
Mhm. The stage is yours.
Yeah. All right. So who has set up your billing account and ready to start this lab? Please type plus or minus. We have 1 plus, please more guys, more. 3 pluses. Oh, that's good. We can wait 1 or 2 minutes, but not more, because time is limited. So, okay. Anyway, we have some introduction, so you have a couple of minutes. I'm going to share my screen. Can you see my screen now?
Yes, Victor.
Yes. So let's start. So our agenda. First of all, we want to try basic GCP services on practice and like touch it by hands and get like a basic imagine about what data processing is, what big data is, etc. So this lab is very basic, is short, because, for example, to build the real data warehouse, you need a team and you need 3 months at least just for the basics. And usually we use dozens of different technologies, and it's quite complicated theme. So, but today I assume you have no previous experience with GCP, because if you have, this lab might not be interesting for you. And I assume you have no experience with data processing and with big data industry, or just have a little of experience. This also works. So we have more people. Let's proceed. Also, please check out my shirt. It's a Friday shirt. Because Thursday is almost Friday. So let's start. Just let's imagine we work at some company. It's a technology company which produces and sells household appliances. And we have a team of analysts, and the team needs to get some answers on many questions. And one of the questions is, for example, customers buy appliances and which age category have bought the most expensive TVs. The most expensive TV is TV about 1,500 dollars, zloty, hryvnia, whatever. It doesn't matter really. And we have 3 age categories, like under 30, from 30 to 40, and above 40. So the first category, the second, and the third. How do you think which category wins? Type 1, 2, or 3, in your opinion? Come on, guys. Do you have a keyboard? 2, 1, 3. Please type more. Okay, enough. To pass this lab, you need the only tool, your browser, and it's enough completely. So please open your browser and open 2 tabs. The first tab is console.cloud.google.com.
Yeah, Victor, you can send this.
Yeah, I will.
To
Sure.
the chat.
Yes. So just click on this link, and this link will be your main theme if you want to work with GCP. And the second link, I have prepared some scripts for you. And please open this link in a separate tab. So this is basically all you need to be set up. So it's easy, let's proceed. So to answer this question, we have a data. Let's imagine we have 2 sources. The first source is customers. It's a list of customers where you can see first name, last name, age, email. Just imagine we retrieve this data from some API, from maybe CRM API. Usually it happens in the real world. But for our lab, I just generated it within my script. But in real life, usually we retrieve this data from some DPI, or some upload this data to our system, etc. And the second table is sales table. Sales table where we have some sort of sales statistics. Here we have client, have purchase date, product, price. So let's get prepared. So open your GCP console, and first of all, we need to create a new project for this lab. You need to type here. So this is a search window, and you can type some information here and find any resource on GCP, any page. Also, we can find it here in the left panel, but I usually prefer to use this window. Just type create project. You see, I found it. Please follow me. And you should see this page with new project dialog. And let's name this project, for example, Big Data Workshop. And there are two entities. The first entity is project name. It can be anything, doesn't matter. But if you push edit, here we have project ID. Project ID. And project ID must be worldwide unique. And if we have a lot of people, to make this worldwide unique and to avoid conflicts, I will ask you to generate some salt. I'm sure you're aware what salt is in programming. So we are going to this page.
And Victor, and please send the link to the chat as well.
Yes, of course, for sure. So just use this button to generate some random numbers and digits. And you can, for example, take this part or this part. I will take this. And I would like to have project ID similar to my project name. So I'm going to use this kind of salt, like project ID is equal to Big Data Workshop dash and some salt. So this guarantee we will have, or we have unique project IDs, because Google also tries to generate some random thing, but there is a case when you have similar project name and project ID also will be similar, and there is a little chance of conflict, as we checked yesterday, by the way. So leave organization and location the same, so no need to change this, and be ready to click create button. And actually, this is the most difficult part of this lab, I hope. So please, let's click create. Yes, my project is creating. This should be created soon. Usually it takes a few seconds. Yes, it's created. And you will see your project. You need to select your project here. Yes, I have a lot of projects, my personal projects, but I need to select my project here manually. So be sure you select the correct project. And also be sure you use your personal account. For example, I have a few accounts, but you need to choose the correct one. It's the second thing. Please tap plus or minus if you see the same on your screen. I'm waiting. Plus or minus? Plus. 3 people. I want more. Don't forget to add salt in project ID. plus plus.
Mhm.
Okay, type minus. I also want to see if you are not set. You can wait a couple of minutes, for example. But if you type nothing, we can't know. So I assume you're ready. Let's move next. So what we're gonna build? We're gonna build like a typical data pipeline where we have a couple of data sources. In our case, it's customers and sales. Usually, as I said, those data sources can be from many API, any third-party resource, doesn't matter, but I have prepared these two files, CSV files. We have two CSV files in my bucket, and I will share these two files with you. And we're going to ingest raw data as is, and we're going to make some basic processing of data, and we're going to run some analytics query to answer our question. This is what we're gonna build today. So let's get familiar with the heart of each GCP data warehouse. You heard about it today on the presentation part of this event. It's BigQuery. So BigQuery is an analytical data warehouse database that can handle and process petabytes of data. Yeah, you saw the numbers. Numbers are really giant. But we don't have a lot of data today, so data are pretty small. So, by the way, BigQuery can process giant amounts of data very frequently, but it's not true about some other services we use today. So I chose relatively small data sets. So the third thing, we should go to Google console page by following this link. By the way, how to see annotations here in this Google chat, in this Google slides or something? Oh, I see annotations. Oh my God. Okay, that's good. So you may follow this link, but I would suggest you to type, if you are in, because this, to type here BigQuery. Yeah. And you should see this service and just click on it. And you should see this window. This is a BigQuery user interface. So here you should see your project. Yes, click on this project. And we are going to create a data set. The name of this data set will be curated. Please be careful, because if you make any mistake, our pipeline will fail. And so please leave all default values here and just push create dataset button. So we should see new dataset. So the dataset is a collection of tables usually. And I'm going to wait a little. Some people are fast, some people are slow. It's okay. Please type plus if I can move on. Yeah. Cool. And yeah, that's cool. And we are going to create a couple of tables for our data here. So let's click on our created data set. And let's click create table. Yeah. So let's type table name. The first table name will be sales. Yeah. And you know each table should have what? Should have a schema. You can add schema here just using UI, but we won't do this. Please type, not type, push this button, edit as text, and you can place the schema as a JSON. I will share it with you. Sales schema.json. Yeah. I share the link and I'm going to copy this schema. So here you can see some fields like name, first name, last name, etc. This is a schema for sales table, and I'm going to pass it here. Yes, leave all values default. I'm not going to change them. And push create table button. Let's create the second table. The second table is customers. This is a schema for customers table. And let's do the same pattern. I'm on my current data set. A table. Table name should be customers. Edit schema as text. Let's copy paste schema. What is going on? Copy and paste. And let's push create table button. And here I have two tables in one data set. So let's wait a couple of minutes. Created, create table button. It's easy. All of you are experienced guys, I know. But anyway, don't be ashamed to type plus or minus. 1 plus 2 or that's okay. Plus is okay. So we will come back to BigQuery later a little bit. And right now we are going to work with Google Cloud Storage, or simply GCS. So this is a blob storage that can store huge blobs of data till 5 terabytes. And let's move to cloud storage. So, and please don't close tabs. If you have opened a BigQuery tab, don't close it. Let's use new window, like I'm going to click here, Google Cloud Platform, and open a new tab. Yeah. So I have BigQuery tab opened. And I also have another tab opened, and I'm going to tab here storage. We have a storage. Yes. And I'm going to create a bucket. I'm going to create that bucket. So please watch my screen and then try yourself. I pushed create bucket. What I'm gonna do. Okay, so I'm trying not be fast. Let's name bucket big data dash workshop, and here we claim the same problem. Each bucket must be unique, worldwide unique. So to avoid conflicts, we need to add some salt. Yes, you can just type some abracadabra or use online UUID generator, as I do. Yes. This is for those who could not find storage page. So, and I'm going to put some salt. Yeah. Just to be unique. So let's continue. So here we should choose region. Please not use multi-region, use a region. Let it be locate the location's default location. Type continue, and that's it. And just push create button. So you should see your bucket. Here's your bucket name. And your bucket is empty. So I'm waiting. And please type plus if you're ready, or minus if you want. We wait for you a little. Plus. Each step I see less and less pluses. Wonderful. So cool. Okay. So there are 3 ways to interact with GCP. The first way is using this web console. The second way, you can, for example, use your terminal. Sorry. You can use a terminal and install GCP tools command line tools and interact with GCP, but you need some time to do that. And the third way to interact with GCP is API. And we are going to use command line tools a little, but you don't need to use your terminal on your desktop or laptop. GCP has a beautiful service suite. Here you can see a bunch of buttons. And the second button here is Activate Cloud Shell. Let's push this button. So you will have a terminal, and actually Google spin up a tiny virtual machine with Linux, and it has everything set up, like your credentials, tools, I don't know, everything for your work. So it's a easy way. And right now we are going to copy customers.csv file from my personal bucket. This is my personal bucket. It's shared globally. No, this is their own. Yes, this one. Yes, it's shared globally. Yes, and we are going to copy customers.csv from my bucket to your bucket. And this step is usually called landing. When you land data from some third-party source to your landing place, usually it's a storage bucket. And let's use this script I'm going to share with you. And here we have gsutil command. Yes. And I'm going to copy paste it. Yes, and so the command is pretty easy. This is the cp command. Every one of you is familiar with cp command. It's obvious, and but so you should set this is my source bucket and source file, and you should set target bucket. Just I'm going to copy and paste it. Yeah. Please don't miss protocol part. GS and two slashes. So I'm going to click enter. Google is asking about authorization. Of course, authorize, and data is copied. I don't see the file here because I need to click refresh button. Refresh. So I have customers.csv in my landing button, in my landing bucket. Let's wait a little and type plus or minus. I'm sure you have some previous experience with other clouds, and each cloud has a similar service. And there was a question about Hadoop. You probably heard about Hadoop file system. Yes, HDFS, and usually in the cloud you use Google Storage instead of HDFS. Okay, cool. So here we have BigQuery again. I'm going to share one script with you. Actually, it's not a script, it's a simple command. Please open this page and copy this command. So we are going to interact, we are still in terminal, and we are going to interact with BigQuery using terminal and using big U load command. What this command does, it will load a job. Yes, and this job will upload your file into the table. So please don't forget to copy and paste your bucket name instead of the placeholder right here. And I'm going to type enter. We have running status and the job is done. And I use a small file, but usually files are big. And actually watch what BigQuery does under the hood. It runs a number of workers of nodes, which process your file, your data, and upload to the table. And this is a PG file because it's horizontally scalable, but you can know nothing about it because BigQuery is ops-free service. You can just use this window and work with big data. That's it. If you have some previous experience with other similar services, especially on-premise services, yeah, we have talked about it today. So you know that it usually limited in scaling, and it requires a lot of engineering, of DevOps work, etc. But here you can deliver this work to Google completely. So I hope your comment is okay. And please go to BigQuery button and refresh your page. In the browser, just click on refresh page button. And let's see what we have here. We have our data set. We have customers. Let's click on it. We see schema. And let's click preview tab. And we see our data. So we just transferred data from some file to BigQuery. So we use this, we used a .csv file, but in reality, it might be JSON line. For big files, it might be Avro. So different types of formats. And we even, if I push query table button, yes, and just run select asterisk from our table. Usually set limit 1000 automatically because when you work with huge data, it might cost money. But we have little of data. Can you move it or leave? Doesn't matter. And click run, and I see results. This is my data. I can look at job information. So we see some statistics. Yeah. Execution details. Work time and etc. But I usually look rarely to this part. So please type plus or minus if you are ready. Plus, 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 plus. Okay, it's easy. Let's move to next section. So this is the most difficult section, and it's called cloud functions. So I'm going to do the same. I'm going to open new tab. I click here, open new tab, and I'm going to type cloud func, and you see cloud function. Boom. It requires some time to get prepared. Let's wait. And I'm going to create my first cloud function. What we are going to do right now, we are going to process data. Yeah. So with reality, it might be some cleansing job, some whatever. And usually cloud functions are good for small chunks of data. But if you have 1 million of small chunks, you can process terabytes of data. So let's push create function. And I need a code. I need to, I'm going to share a link. So it's a Python code. Yeah. Так. Yes, and let's pay all your attentions to here, because any mistake will lead us to fail. So let's give a name. Name could be anything. I'm going to call it process sales data. Let it be. It should be not unique. And let's use default region, don't try it. And here is a tricky thing. We should change the trigger type from HTTP to cloud storage. What we are going to accomplish here, we want if file arrives to our bucket, we want to process this file with our function. And what I'm configuring right now, I should set event type to finalize create. This function will be triggered each time when file is uploading to your bucket or re-uploading if you change it. And I need to choose a bucket, browse, and you should have the only one. And please check if you have the same screen, because it's very important. Please type plus. So that's again, cloud storage trigger, event type, finalize create. The most important name could be anything. You can give your name if you want, or your wife. It doesn't matter. Or your friend. Yes, let's click save. And we are going to the next part. Click the next button. You should see the place where you will put your code. So first of all, we should choose a proper environment. So Node.js is the default one, but we are going to run Python. And please select Python 3.7. 3.7. Yes. And what we're gonna do, here we have main.py. Here we have some sample code. We are going to delete it. And I'm going to copy paste my code here. Please don't read it. So code is simple. What this code does? So in that table, sales table, we have one field with name, first name and surname in one field, but we are going to split it out into first name and last name and the upload to sales table. Yes. So this is like just a simple task. And paste this code here. Don't click anything, please. Don't click anything. And the most common mistake, and that usually I do this mistake, I know not very often, but it's very easy to miss. Empty point. Empty point is the name of your function, which actually does your processing. My function has a name main. So this is very important. Yes. And here we have the second file, requirements. As I use some additional libraries, I need to copy paste these libraries here. Where are my notations? I can't copy paste and I can't see annotations. Cool. Okay, maybe I have it in some another place.
It should be on bottom of the screen.
But yes, it should be, but it's not true. For some reason. Oh my God, it yes, I'm a patrons. So please copy paste those two lines and put them here. And please make sure you don't have any not needed spaces, anything, because it's important. So, and before pushing deploy button, you maybe know what you should do, because you see this red dialog box. Google is asking me to enable Cloud Build API because it uses Cloud Build service under the hood to build your code, actually. So I clicked Enable API. I go to here, click Enable. Need to wait for some time. Please be patient. Usually it takes around 10 seconds. Yeah, when it's finished, you can close this window and this dialog box is disappeared and I can push deploy button and waiting for the deploy. So what is Cloud Function? Cloud Function is a service. It's something it sometimes happened. Let's try again. It's a service where you can just take your code, put it here, and Google will build a container and run a container with your code. And you should not care about it actually. So because it's an ops-free service, very easy to use. This is why I chose it to use in my lab because it's very easy to set up. And so we need some time for the build. Other clouds, not all of them, but I know other clouds that also have similar services. But Google, it supports a lot of environments, even Java. So green means success. So please type plus or minus if you have a green build. Plus, plus, plus. Because this part, I think, is the most complicated. Minus. You can try again. You can push here and edit, reload code. The common mistake if you miss, for example, name of the function, of the main function. This is a common mistake. Maybe you chose wrong environment. Please check. It must be Python 3.7, not Node.js. Okay. Sounds good. Okay. For people who
Yeah, now it's all pluses.
Now all passes. Oh, that's cool. Because I was afraid about this step, to be honest. So please click on your function name and go to this window. And we are going to see logs. Please click logs button, and we are going to see what will be happening here. Just reading the logs. So I know all of you like read logs very much. Is it true or not? I don't know. So, and probably you know what we are going to do right now. We are going to copy sales.csv file to your bucket, and this function will start and will process it. if it did everything correctly, of course. So let's move to your storage tab. Let's check if your terminal, if your Cloud Shell is working, because sometimes Google may shut down it because it uses some services, and if you don't need it, actually it has some timeout. So I'm checking, so my console is working. But if not, please click again on this button. But in my case, everything is okay. And I have the last script. I'm going to share the link with you again. Okay. So this is a command, again, cp command, and I'm going to place it here. Yes, you know, we need copy paste your bucket name. Yes. Please don't forget about it. And actually it should be GS like this. Did I have it in my code? Yes. Please be careful. It should be JS column / your bucket name. Yes. I press enter. Press enter and refresh the window. I see my file here. And let's move to logs. Please move your mouse because usually this window refreshes when you move your mouse. Oh, your scroll wheel. And what do we see here? We see here new rows have been added, and function execution took some milliseconds and finished with status OK. What does it mean? It doesn't mean we should have data in sales table. Let's move to our BigQuery tab. And please type plus or minus if you have OK status in the logs. Please, please, please. Okay, we don't have much of time. Loads. Loads means plus. Okay, let's go to BigQuery and refresh the whole window. Yeah. I'm going to, and let's go to your sales table. To sales table, and what you can see, preview button, you should see data. So these data are from the C-suite table we just processed, and in the source file there was not first name, last name. It was like a one field. Yes, please type pluses, plus or minus if you see the same. Cool. Cool. So we have just prepared data, and the final steps, the final step, actually. The final step, we can run some analytics query. I'm going to share the link with you. Okay, so please copy paste this query. I hope there is no mistake because it was done pretty quickly. So let's go to BigQuery again and open editor. If you don't have this tab, you can push compose new query, doesn't matter, and copy paste. And push run button. It will start BigQuery job spread around the cluster on GCP, but you don't care about it. You don't care about it, and we have the result on our. So the answer is above 40. So, and please don't type plus or minus if you have the same result, but please type plus if you win. You remember I asked you at the beginning, at the start, which group wins. So the correct answer is above 40. I assume the people above 40 are rich.
Guys,
And
just in case you are writing pluses to only panelists, so attendees don't see your pluses. So please choose all panelists and attendees, or if it's in Russian or Ukrainian, участники и панелисты, кажется так. Thank you.
can you say it in Polish?
I have no idea actually, but I believe they have English version.
Win, 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 win. Actually, our lab is over, and we ran analytics query. We have the answer. What I would like to tell at the end. So we have been doing all things manually by hands. Nobody usually does it by hands. So if you are in the cloud, you usually should use some sort of orchestrator. Yes, like a conductor in orchestra. And the industry standard of data flow orchestration is Apache Airflow service, and it's available in cloud. It's available in cloud, and it's called Composer in GCP. And I built. We didn't run it because it's like resource consuming service, because it's a cluster service. You need 3 nodes at least to run it. 3 nodes at least, and it usually takes more than 20 minutes for spin up, for deployment. Yes, and I just built our workflow just to imagine what we would have if we would do that in a real project. So we will have some sort of, Composer web UI, and here is a workflow, and green squares mean all jobs were successful. Yeah, and this orchestrator schedules your job. There are plenty other cool technologies for big data. We could not touch today. For example, data flow. It's a really awesome service. Yes.
Yeah, basically, yeah, there are very a lot of technologies we haven't spoke about, like, and in a feedback form, we would like to hear from you, like what kind of thing you would like to hear in the next sessions we are planning. So please pay attention to that. So because based on your feedbacks, like we will be planning new sessions. And yeah, basically here our lab is finished, and hopefully you all enjoyed that. Of course, it was like basic level. We will plan to increase complexity for the next sessions. And by the way, I have couple more things to tell about, and a couple announcements. 1 second, I will try to share my screen again. Share. Okay. All right, I will scroll everything down. And by the way, one thing I would like to mention. So of course that was basic, and how we can continue learning, and how we can improve your knowledge about data and start working with GCP. So of course, one of the greatest things like in GCP, GCP has very good materials for exam preparation, and the most close one to the topics we were discussing today is professional data engineer. I will left his this registration link here, like in this presentation will be shared among you. Another good thing is it's a book I really recommend if you like to work with data in the future. So it's Design Data Intensive Applications. It covers not only like big data, but analytics and topics about streaming processing, and topics about choosing the right database and storage for your work. And yeah, again, very recommended to read. One of the greatest books, like which we have really good feedback, and like from people who already went through this, and I recommend it personally. So it is a really good book. Again, we will have more events like this, and like more advanced in the future. So keep an eye on our announcements, and we will be happy to have you on our events next times. And in addition, we have one announcement. Like in nearest future, we are planning to start specialized program for beginners in data, right? And this program we're going to run in different locations in SoftServe, where during the 2 months we will be offering people to go through dedicated training, like for people who didn't have experience with data, and we will be teaching all the stuff, all the topics you need to understand working with data within our company. And moreover, this is like kind of offering to have a job if you want to work with big data, even have no experience with that. So it means you join our company and learn for 2 months, and then join our projects, helping us working with Google. So currently this is more like first wave we are planning is going to be for Python developers who have Python experience but have no experience with big data. And yeah, keep an eye on our vacancies and announcements. This might be good opportunity for you if you want to have smooth switch between like directions from like Python engineering to data engineering. And we will set up everything to help you do so. If you have any other questions, we still have a couple of minutes, to answer them. So feel free to post your questions and in Q&A window. And in any case, thank you very much for participating this event today. We are happy to have you here, and we're pleased you attended this event and spend this time this evening with us. All right, guys, I see no questions. So at this moment, I would like to thank you again